Hello? All right, 4.6, using calculus to graph functions. So now we have a lot of stuff that we already know, a lot of stuff we don't know. And so we're going to go through and talk about a whole bunch of these things. Okay, so first thing, using calculus to graph functions is not directly assist on AB and BC exams. However, it is essential that you know how to the first, second derivatives provide information about the function and its graph, including intervals where the function increasing or decreasing, local and absolute extremas, intervals where functions is concave up, concave down, and inflection points. For these reasons, this section may be still covered in your course. That's why we're doing it. So it's basically all that we've done. Find the domain of F and any intercepts. Identify any asymptotes and examine end behavior. Find the derivative. Use it to find critical numbers. Determine the slopes of the tangent lines, critical. Also find the second derivative. Use the first derivative test to find intervals where it's increasing or decreasing. Find local max and min values. Use second derivative test to determine the intervals of concavity. Graph the function using information gathered. So, what should I start with? Domain. What's the domain? All real numbers. Very good. So, all real numbers, we don't have any like weird things like dividing by zeros or square roots, non-real numbers. Okay, or anything crazy. All right, so end behavior. Okay, so so what is this one going to look like, you guys? There we go. Looks like Childish Gambino right here, right? Okay, yes, I did go there. Yeah, this is America. Anyway, so we know that's ending up on both sides, right? So both sides, left and right hand side, is going to end up because I have a even power. My leading coefficient is positive, and I have my greatest degree, x to the fourth. So that tells me I'm going to have n there, right? So next thing, let's go through and first derivative. So f prime of x is 12x cubed minus 24x squared, right? Yes. Okay, so what should I do with that information? I want to hear from people that I don't hear talk all the time. I want Tinkerbell. Tinkerbell, tell me, what should I do next? What should I do next? Come on. Yes, very good. Factor it. Factor it, and then when I factor it, I do what? Equal to? That's it. Okay, very good. So factor it, so it's going to take out a 12 and x squared I'm left with. X minus 2. Okay, and if I set that equal to 0, right? I know I'm going to have critical numbers where? At x equals 2 and plus or minus 0. Very good. All right. Plus or minus 0. Okay. So those are my critical numbers, right? Okay. Now, so, okay, that guy. What should I do next?
I mean, those would be the extremes, right?
Uh-huh.
So you're just plugging those points?
No, not yet. Not yet.
Oh, yeah, put the x back into the function, original function. What are you trying to find? Oh, the slope? Oh, it's the whole point. Okay, yeah, just second derivative.
Find the second derivative, right? Okay, let's do that. All right, so second derivative,
You forgot to find the intercepts.
the intercepts,
Yeah, like the zeros, right? The roots.
the roots. Ooh, that would be good too, right? Okay, we could do that. All right, so let's see. Where am I at now? Okay, yeah, I can do that too. So f del prime x is, what is it? And plus, minus. Very good. All right, I need to hear from people I don't normally hear from. What goes next? Before I do that, set it equals 0 and factor. There we go. All right, good. So we go 0 equals, what am I effing from that? So it's gonna be 12 x, and I'm gonna be left with there we go. So now that I do that, I get x equals and 4/3. Now, from the second derivative, that's going to tell me I have what? Points of inflection, right? Points of inflection. So that's where it's going to be changing concavity, right?
Yes.
Okay, very good. So, let's see. I know that I'm going to have mins and maxes at 2 and 0. I'm going to have changes of inflection at 0 and, or changing concavity at 0 and 4/3. Okay, so what else? Let's go back to the checklist. All right, and asymptotes and end behavior, find the domain, any intercepts. Okay, we could do that too. Intercepts. What does an intercept do for me? Wrong way. What's an intercept do for me? So to get an intercept, I do what? Set y equal to 0, right? So I'm going to set y equal to 0. And what else could I do? I know, but you're texting, so. Okay. Set x equal to 0 also, right? I can set y equal to 0, and then I set x equal to 0. That's going to give me my intercepts, right? So I'm going to see. So when I have x is 0, I get a y value, right?
Yes.
So when x is 0, I get 0. Very good. And then when I get y is 0, what would I do for that? So that means I set it equal to 0, right?
Yes.
So it would look like this. I'll erase it here in a second. So bless you. All right, 0, 0 equals 3x to the 4th minus 8x cubed. Factor, so it's going to be x to the, and I have 3x minus 8 equals 0. So it's going to be right here. I'm going to have what? So x 0 and x is what? 8/3. So I'm going to have two places in which that the x, so right here, I have two places now out of it. So now it's going to be at 0, and it's also going to be at 8/3. So, okay, there's all kinds of information I'm getting from this. Okay. So I know I have those. So I know I'm going to touch the point at 0, 0, right?
Yes.
I know I'm also going to touch it at 8/3 and 0. So 8/3 and 0. So let's see, that's going to be 2 1/3, so it should be right here. No, 2 2/3, right? Sorry. There you go. So it should be right there. So now I got those on there. So I know that my graph has to go through those points, right? Yeah. Okay, that's good. All right, so let's plug in our critical numbers to tell me what my values are. So for my critical numbers, that's these right here. So those are my critical numbers. So when I plug in 0 for my x value, I get what? I plug in 0, I get 0. Okay, that's easy. That's why I did that first. Okay, so the next one, I'm going to plug in 2. I'm going to plug in 2. So if I plug in 2, I'm going to get 3 times 2 to the 4th minus 8 times 2 to the 3rd. So this is, let me see, 3 times 16 minus 8 times 8, 64, 48. So negative what? Negative 16? Something like that? Yes? Okay, so I get negative 16. So here I have a critical point when 2 comma negative 16. All right. Okay.
That was such a great sound.
Okay, so I have a critical point. So 2, negative 16. So on my graph, 2, negative 16, right about here. So what do you think that's going to end up being? Probably is going to be a min, right? Yeah, that's going to be a min there. Okay, so, and I have changes in flexion, right? Changes in inflection here. So, oh, okay. So because of that, I'm going to have to do some test for the second derivative. All right, so to figure out if it's a min or max, let's plug in 2. Plug in 2 into the second derivative. Okay, and that's going to test my concavity. So this would be 24. That's a positive number, right? Yeah. Times, and this would be 6. That's going to be 2. That's positive. So positive is positive. So remember, positive. It's opening up, right? Yeah. Opening up. So therefore, that one's going to be a minimum. So we have a minimum here. Okay, if I do the same thing for 0, let's see what we get at 0. 0, oh crap, I end up with 0, right? Now, when I have 0 and I'm plugging in my critical point, what's that tell me? It's not, so it is going to still be one of my points of inflection, right? It's still a critical point, so am I going to have a concavity right there? No, I'm not. I'm not going to have concavity. It's going to change concavity at that point. Okay? But I'm not going to, I don't have either of them. I'm not going to be concave up, I'm not going to be concave down, right? So at that point, it's neither. So it's changing concavity from there. All right, so what else do we have? Let's go back. Let's see, we did first derivative test for increasing, decreasing. All right, let's find those. Ah, crap, keep pressing the wrong one. All right, so first derivative tests. So let's take a look. Let's see, what is it going to be at -1? So first derivative test at -1. -1, so this is going to be a positive right here. This is going to be a positive, right? And this is going to be a negative, so it's a negative, so it means it's going to go down, right?
Yes.
So that means that over here on this side, since I'm not going to have any more changes, I know that everything this way has to be going down, right?
Yeah.
Everything on this side has to be going down. So all this is going to be negative. Okay? All that's going to be negative. So let's see. If I know that's going to be negative, let's find a point then. So let's put a point on here. So -1 up to the first function. So let me see. That's going to be, that's going to be what? 3 minus positive. So that's going to give me what? 11, right? There we go. So I know because of end behavior, remember? Okay, end behavior, both sides are going up. So I know that from right here, it's going to be something like this. All right, let's take a look. What else do we have? Let's look at, let's try 1. Let's try 1. Let's see what 1 would be. Actually, changing concavities at 4/3. Yeah, I can do that one. All right, so let's try what 1 would be. So let's do from 1. So 1, just +1, what is it going to be right here? So if I'm plugging in to first derivative test, that's going to be positive, and this is going to be negative. So the whole thing is negative. So I know right here it's going to be negative. So I know all this is going to be going down, right? Yeah. So it's all going down. And I have an inflection point at 4/3, right? Yes. So that means at 4/3, let's see, 4/3, plug that into there. Oh, crap, I don't want to do that math. That sucks. Huh?
Yeah.
The second derivative is positive.
Second derivative is going to be positive.
It's concave up from 4/3.
So it's concave up at 4/3? It's not. Because 4/3 second derivative is going to be equal to 0. That's the change in concavity there.
I mean above 4/3.
Oh, above?
Yes.
Okay, so right here, it's going to be, so I know that at 4/3, which is going to be about 1/3. Oh, please work today. All right, so should go here. Something like that. So here is the point where it says it's going to change concavity. I know that down here it's going to be opening up. It should, because it's changing concavity at this point. So let's take a look. I know that the slope should all still be negative. Okay, so now on the other side of 2, let's see. Let's do like 2.1. I'm doing 2.1 because it's a little bit more than 2, right? Okay, so let's see. So if I do first derivative, so 2.1, this is all positive over here, right?
Yeah.
Okay, 2.1, this is going to be positive, right?
Yeah.
That's why I'm using 2.1, because I need a positive, so I know that the slope is going to be positive from here, right?
Yeah.
So let's see, that goes up. And behavior there, right? I don't have any more changes. There's no more change in concavities. There's no points of inflection. There's nothing else. So my whole graph should look like this. So from a function, we can go through and read all of that and actually be able to graph it with some accuracy. So let's see. Is that what it come out to be?
Yeah.
Yeah. I'll graph it. Let's see. Okay, so my function was 3x to the 4th. Yeah, 3x to the 4th minus, right? 8x to the 3rd graph. There we go. Looks not bad. Well, what's different here? Hold on, let me
The
see.
scale.
Yeah,
Scale. I go from basically -2 to 4. This goes down to -20. Okay, let's match that. So menu, window. So let's go negative, what was it? -2, 4, and y min, what was it? -20?
Yeah. It looks like spot on.
And y max should be
It was 20.
30?
Oh.
Was it 35 or 30? 35? Okay. There we go. Let's see. Bam! Look at that.
Look at that, son.
Woo! Man. Good job.
Yo, I don't know. I'm
Okay. It's.
kind of like.
Alright, is yours not right?
Okay. Oh no.
Are you melting?
It's because I said I don't know how I'm comfortable.
Oh, okay. I thought you said I don't know how I got this.
Oh.
Okay, sorry. Alright, so let's take a look. Alright, so all we're doing now is just checking it with these rules, right? What would be the issue on this one here?
0 in the denominator.
Yeah.
0 in the denominator. Okay, 0 in the denominator, so that means something's going to happen at 0, right? Okay, so now, do I have a horizontal asymptote? How do I check for asymptotes? Are the degrees the same?
No.
No.
The degrees are not the same. Which one has a bigger degree?
Bottom.
Bottom. Bottom has a bigger degree, so therefore it has a horizontal asymptote where? At 0. Okay? If the top is bigger, by how much? By 1 degree, I have a diagonal asymptote. Okay? I have a diagonal asymptote. And I get that from doing long division to figure out what my diagonal asymptote is. Alright, and if the top is more than 1 degree bigger, what does it go up to? Then I wouldn't have one, right? Okay, so what would I do with the bottom? Top and bottom, what would I do? So let's say, for instance, top and bottom, I could factor them. What if top and bottom have a common factor? That's going to be a whole. That one's not going to be an asymptote for the denominator. It's going to be a whole. So it's not going to go to an asymptote. You're just going to go to a spot in which that point right there is going to be undefined. Okay? So the same checklist, the same rules apply for all of it. Going through, set it equal to 0, find my y-intercept, my x-intercept. Okay? That's basically it. Yeah, we don't need to actually go through and keep doing a whole bunch of the same graphs. You just have to check for those things. That checklist, that's going to help you out for all this. Like I said, this isn't a exact AP exam question, but we do a bunch of questions that pertain to all these. All right? If you guys want some graph paper, I have graph paper for you too. All right? I think that was it, because this unit, that's all it is. Yep, that's it. Yep, don't forget, like and subscribe.